All right, hello everybody. Welcome to writing true unit tests using dependency injection and mocking. Catchy title, I know, but make sure you knew what to expect here. I'm Alex. I'm a senior developer at a company called Design It, based in Bristol in the United Kingdom. I'm also a Salesforce MVP, Salesforce certified, lots of things, and various other bits. My email's on there and my Twitter handle's on there if you want to reach out to me at any point after this. So let's get started. So first things first, forward-looking statements. While I'm not a Salesforce employee, I will be talking about a feature that is not yet available. Basically, don't base any purchasing decisions off anything I say, only off what's on the salesforce.com website. So to begin with, I just want to do a little bit of audience participation. So if you could all stand up for me a second. If you're on your laptop, pop it down for a sec. I promise you won't miss anything important in this next 10 seconds. Right, so anyone who's a developer, pop your left hand up. Okay, anyone who's written unit tests, pop your right hand up. Okay, anyone who thinks they could do better at writing unit tests, sit down. I would sit down, but the stools aren't great. Okay, so we've got one guy who might not get much from this session, but we'll see. Okay, so in terms of what I'm going to cover, I'm going to talk a little bit about unit testing, what unit testing is, an integration or application test versus unit tests. I'm then going to go through a little bit of theory around dependency injection, inversion of control, and stubs and mocks, and try and hopefully demystify what those mean with a few simple code examples. I'm then going to go into the practical application of that theory. The code samples I use are purely for demonstration. I wouldn't recommend you go and use these in the wild, but they're just to try and, as I say again, demystify some of the theory that I'm going to be talking about and put it into context. I'm then going to touch on some patterns and frameworks used with stubbing and mocking. So not just on the Salesforce platform, although all of the code samples in this are Apex code, but also just talking about some of the frameworks available for other platforms as well. What this isn't going to be is a deep dive into using things like Apex mocks or the new Stub API, which I will mention. Unfortunately, the sessions are not quite the right way around. There was a great session on Tuesday by Jesse Altman, which is worth watching back if you can find it, about using the new Stub API. So yeah, I won't be covering in quite that level of detail. It'll be more a high-level thing to hopefully make some of what Jesse said make a bit more sense. What this is also about is about bacon. Now, I was very lucky, I'm based in the UK, hopefully you can tell that from the accent. I was very lucky to have Peter Chittum as my session coach, and he's an American now living in the UK, and he pointed out that Americans wouldn't understand what streaky bacon is, which is in some of these examples, just, it's not a complete irrelevance to what's going on. So streaky bacon is basically American bacon. The other bacon we have in the UK is back bacon, which is sort of Canadian bacon plus. But for the purposes of this, so long as you understand that when I say streaky bacon, I'm just referring to standard bacon you see. It's not actually relevant, but just so you're not sat there going, hey, what's streaky bacon, and not listening to what I'm saying. Okay, so first off, let's talk about unit testing. So I've nabbed a couple of quotes off the internet here. So we've got unit testing. Unit testing is basically testing the smallest testable parts of an application, which are called units. And the key thing here is that you're testing them individually and independently. Now, the other main form of testing, there are tons of types of testing, but the two I'm going to focus on in this are unit testing and integration testing, which a lot of people sometimes call application testing. They're not necessarily the same thing, but they're close enough analogs for the purposes of what I'm talking about. So integration testing is where you start to test all of the individual modules in your application or whatever else together and seeing what they do. So it happens after unit testing. Once you've validated each of the individual pieces, you then start to see how they play together as a whole. And then it happens before validation testing, which is more your sort of end user stuff. So just to cover some of these off as a sort of versus thing, unit testing, and this is key, pay attention to this slide because there'll be questions on this in a second, test the smallest testable part of the app. The modules are tested independently, and they're primarily for the benefit of the programmer, the developer. You wouldn't expect an end user to go look at your unit tests and make sense of them. They might make sense of some of them, but that's not what they're there for. So then we have integration tests. So these test the real-life operation of the system. Because you're not testing the individual little bits, you're testing how they operate together. It's more like what's going to happen when your users interact with it. And they're more likely to be understood by non-programmers, or at least the goals of the test are. Because integration tests are still going to be written in Apex, JavaScript, whatever language you're using for the most part. But if you explain to your end user, what I'm testing here is you click this button and a picture of some Canadian bacon appears on the screen, that's a concept they'll understand. Whereas with the unit tests, you may be going off to some services, calling off to an API. That's not necessarily the sort of stuff that you're testing there that they're quite going to get what's going on. So here is a very, very basic example of a couple of classes. So I've got my bacon controller up at the top there. Could be a page controller, could be some arbitrary controller for something else. It doesn't matter. It's a poorly named class, but it's nice and simple for the purposes of this demonstration. I've then got my bacon service, which has got a static method that encapsulates a query to go and get all of the bacon in the database. Who's familiar with hiding things behind service classes? Queries, DML, all of the system libraries. People use that sort of pattern. OK, that's good. Because to get a lot of the stuff I'm talking about to work, that's the sort of stuff you're going to want to be doing. And there's big advantages to doing that, which I won't go into. But it allows you to do things like DML-less tests. And it also means, in particular with the queries, you can have set lists of fields that are returned from your queries in every part of your application, which will make you less likely to get field not found errors and things like that. But that's a slight aside. So I've written some unit tests for this method, for the controller. So as you can see, two very simple ones. One that basically tests, if there's no bacon in my database, I get an empty list, I don't get a null pointer exception, nothing explodes, that sort of thing. And then another one where I've got some streaky bacon in the database, and that comes back. The asserts aren't as good as they could be, but we're not talking about that today. So what I want you to think about now is this a good unit test? Who thinks it's a good unit test? OK? All right. Why is that? Well, it's not really a unit test. We're not testing the smallest testable part of the app. Now, I know I only showed you the service being used in one place there, but that doesn't mean that one of the other developers in your organization might not pick it up and start using it somewhere else later on, or it might have been a pre-existing thing. I didn't necessarily write it just for that example. So that really needs its own test to prove what's going on. But also, I'm testing it as part of my testing of the controller. If the way that bacon service works changes, the test of my controller might break later on. So I'm not proving the logic in the controller. I'm proving the logic all the way down my call stack. This is more along the lines of an integration test. If we think about it, if it was, say, a page controller, whatever the page does, it displays a list of bacon on the screen, let's say, for the sake of argument. This is basically the closest thing you can do to a end user's test of the system while still staying within Apex and not going into UI testing and stuff, using Selenium or something different. So this is actually testing the application as a whole and how the modules interact together, the modules being the classes in this case. So before I move on to how we can write a better unit test, I want to go through a little bit of theory. So this is where I'm going to talk about inversion of control, dependency injection, and all of that sort of stuff. So we'll start off with inversion of control. And the simplest way of explaining inversion of control is that it separates the what to do part of your code from the when to do it. So clients provide the when to do. So they say, when I call get bacon, I want you to do all of this logic. And they might contain a little bit of logic themselves, but not too much generally. You want thin controllers, fat services, ideally. And then your services provide the what to do. So in this case, it's go and get the bacon from the Salesforce database. It's not go and get the bacon from some external API or whatever else. The thing is, our controller shouldn't have to care about that. Wherever our bacon is stored, why should the controller care? All it knows is that it's using the prescribed way of getting bacon or whatever other object, records, data in your org. So then the responsibility of which what to use, and this is where things get a bit complicated, and I'll show a little bit of code in a second to explain this, is given to the creator of the client. So whatever initializes the controller determines which services you should be using at any one point. And it's quite hard to see that at the moment because I've been using a static method in a class, but you'll see in a second when we move on to instance things, there's some very powerful things you can start to do. So what you should be really doing when you're doing dependency injection is, inversion of control, move on to dependency injection in a second, is coding against interfaces rather than implementations. So this is why I'm saying you want to start using classes with instance methods, because static methods can't be part of interfaces. So you define an interface that says I've got a bacon service with a getBacon method, and I'll show you the code in a second. And then what that will allow you to do is then write more flexible code, because anything that implements that interface can be used by your controller. It could be in some cases that you do want it to go get it from an API. Other times you do want it to get it from the database. You can do some clever things like having context-dependent services. So if someone comes in from the accounting side of the app, they'll use a different service to if they come in from maybe your sales side of the app. So then once you've got inversion of control, you can then start looking at dependency injection. And they're very, very similar concepts. I mean, dependency injection, as it says on the slide, is a specialization of inversion of control. So dependencies are not explicitly constructed in the class or explicitly called in the case of my static method I had up earlier, but they're instead injected. So that can be passed in by constructors or setters, and we'll go into some more complicated ways of how you can go and grab your dependencies a bit later on. But the simplest one is to use a constructor. So we'll start off by doing a little bit of refactoring of our service. So we'll start off by creating an interface for the bacon service, saying, right, if I have a bacon service, then this is what it has to implement. At the moment, there's only the getBacon method. There could be a bunch of other methods in there, but we're only going to talk about that one for now. So now I've created an implementation of that bacon service down the bottom, and you'll see I've changed my static method to an instance method. Very, very simple implementation of what's going on, exactly the same as before. So now the bigger changes happen inside my controller. So in this example, I'm using constructor injection for getting the services that it requires. So basically, the constructor has an argument for every single service that your class might need, and you pass all of them in when it gets constructed. Now, there's one thing I realized this morning, which is talking in the context of a page controller, this doesn't quite work, and I probably should have taken the word controller out of the class, and that's because you can't pass arguments to the constructors of page controllers. But if you just ignore the fact that it's, looks like a page controller for now, this could be any arbitrary class. I'll talk a little bit about how you can get around it with page controllers near the end. The point is, I pass in the bacon service, keep a reference to it. I know there's only one method that uses it at the moment, but there could be a bunch of them in there that uses other things. And you'll see I've just done a quick refactor so that I'm now calling my instance and calling getBacon on it. So once you've got dependency injection sorted, this is when you can start thinking about using stubs and mocks. So stubs and mocks are things that you would use in your test classes. So instead of passing in a real implementation of whatever dependency it is you're testing, you can pass in a fake one that does whatever you like. So what they allow you to do is decouple the different parts of your application within your tests, because in my controller test, for example, I'm only going to be calling the mock implementation. I don't care what the actual bacon service does. All I care about is that my class can use an iBacon service properly. That's it, for the purposes of a unit test anyway. So we've got stubs and mocks, and they're very, very similar. Stubs are, say you can inject them into your clients during your tests. They're very, very simple versions of mocks, essentially. Now, that's a gross oversimplification, but just for the purposes of this, it makes it nice and simple. But stubs tend to just be dumb and return data. So in the example there, it would probably just return a hard-coded list, a hard-coded empty list, a hard-coded list with some stuff in there. Mocks are stubs ++, if you like. So mocks are much more flexible than stubs. Generally, you will have methods for mocking various things like throwing exceptions, what gets returned in each method, validating whether methods are being called and how many times, that sort of thing. So they also perform verification. Like I say, stubs are dumb. They just return data and let your code continue along the path that it's meant to, whereas mocks are smart and actually allow you to verify that the right things are happening within your application. So I'm now going to talk about some of the practical application of what I've been talking about and show you, as I say, a couple of bits of sample code that I don't recommend you go out and copy and use in the wild, but will show you how these sorts of things actually work and interact within a unit test. So the first one, I'm going to just do a couple of stub implementations of my interface. So I've just created a couple of inner classes within my test method that cover a couple of different scenarios that I want to test for my controller. So we've got the very simple no bacon service at the top. So you'll probably see that this is mimicking the first test that I did where there was no bacon in the database. And then we've got the streaky bacon one, which again is mimicking the second test where I had the one record in there, which was streaky bacon. So nice and simple, nothing too complicated there, fixed data coming back. As I say, stubs are dumb. Oh, pardon me. So if I then rework my test class to actually use these, this is basically what it would look like. So you see on line 8, I'm instantiating my controller, and I'm passing in the no bacon service, and then calling get bacon. So I get a list of results, and my assert is that I get no bacon back, because that's what the stub returns. And the second one, I'm passing in the streaky bacon service and asserting I get one record back. So you're probably thinking, well, these tests are a bit, weird. What is really going on here? Well, what I'm really trying to do with the unit test is test the bacon controller and the bacon controller only. So by removing the dependency on what the bacon service is doing, the bottom service, I can just look at the logic that's in my controller. So this is an overly simplistic example where it just returns the list. But imagine you've got some logic in there where if there's no records, it throws an exception. You can test that scenario very easily without having to make sure there's no records in your database. I mean, you could insert, say you inserted another record and that created some bacon, okay? And you had to insert that for this test to work. That's a bit annoying. You have to insert something, the bacon gets created or the other record gets created, then you have to delete that to make your test work. You're removing all of that nonsense away, all of that brittleness. That's an extreme example of how things can get. But, even very simple things, this just removes a lot of the headache. So now we're going to move on to mocks. Now, mocks are really where you want to be. I'm not going to say all of your testing because it's development. We never deal in absolutes. But really, mocks are where you want to be looking at where you can get the most value from. Because as I say, mocks are smart and stubs are dumb. And mocks are a lot more flexible. So this is, I say, do not take this home and go using it. Use one of the proper mocking frameworks, which we'll talk about a bit later on. But this is an example of how you could, if you wanted to hand roll a really basic mock for yourself. So I've got a method there. Well, we'll start off with the mock getBacon method. So this is where I can mock my getBacon. So I can say, right, when that method gets called, I want you to return this list. So you can see straight away that this is going to allow me to replace my 2 stubs with this one class. Not just my 2 stubs, could be an infinite amount of stubs that I have for that getBacon method, and I can replace them all with this one class because I can just switch in what gets done. The other bit to look at is lines 4 and 5, where I'm just getting the expected methods to be called and the methods that were actually called. So this is a very basic example of verification. As soon as I mock the getBacon method, I'm expecting it to be called, and then I'm adding it to a list when it actually gets called. And then in the verify method, I'm just doing a quick check to make sure both of those lists are exactly the same, or sets rather, are exactly the same. So everything that I expected to be called was called, and the only things that I expected to be called were called. Now, if you use a proper mocking framework, all of this will be hidden away from you. You don't need to roll your own. You can see how many times things were called, and you can do much more complicated mocking of methods. But this, as I say, is just to explain the basic concept. So how do my tests look when I start to use a mock? Well, I can replace my two stubs, as I said, with just this mock called with different parameters. So the top one's called with an empty list, and that mimics my no bacon stub. And then the test is exactly the same from that point, apart from I call verify at the end to check that everything was called that I expected. Because one of the things I'm trying to check here is the internal logic that's going on. This is why I was saying this is for programmers, not for your end users. Because it could be that I get an empty list back, but it doesn't actually go off to the bacon service to get that, which isn't a great thing if the whole point of the page is to display everything that the bacon service returns. And then the second one is exactly the same, except this time I pass in a list with the single item, and the test follows on the same way, and the same logic applies. What I want to check is that I'm actually going to get the records I want from the place that I said I would get them from. Because that is really the purpose of the controller. It's just to get this list from another place for the purposes of displaying it on a page or for doing whatever else. So I've shown you those examples and gone through it all, but I keep repeating the fact that you shouldn't use that code. You should be, using some framework. So first, I'm going to just talk about a couple of dependency injection, inversion control mocking patterns, and then I'll talk about some of the frameworks that are out there. So the first one that I showed you and I spoke about was constructor injection. So constructor injection, very simplistic. You pass all your dependencies in through the constructor. This looks very similar to how Angular does things, except Angular has got an extra thing called a service locator in the background. We'll talk about service locators in a couple of slides. The other one that's fairly common, and this looks a bit more like what you would get if you were using something like Spring. You can do constructor injection with Spring as well, but people tend to favor doing this, and they use XML files to configure where things are. But you can use setters to set each of your services. You could equally use a property, doesn't have to be a method, but a method shows the point a little bit more explicitly. Now, those two patterns are great, but they're pretty simplistic. Now, there's a couple of other things you can start to look at. So the first one is using a service locator rather than actually injecting your dependencies. So I spoke about Angular. Now, Angular service locator is really clever, and you mark out your constructors with which services you care about, and then it injects them for you. Unfortunately, with the way Apex works, it's very difficult to do that on the Salesforce platform, nigh on impossible because of the lack of reflection and a few other things. But you can still look at using the service locator pattern just in a slightly different way. So what a service locator does is you say, I want a service that does this. So in this case, I can say, I want an iBacon service. And it will go off, and based on information that it knows, or it could know nothing, it could just be a dumb one that returns the same thing every time, but it could be based on configuration, the user profile, custom settings, all of this. It can then go off and get the appropriate service for that user or that context or whatever else you want to do and return it to you. So the service locator starts to allow you to do things like storing dependencies in configuration, as I've said. So then, you can start to do some really, really clever stuff if you want to. So I'm going to talk a little bit about frameworks now. So there's, the only one that I really know of that's worth using, and I don't want to blow smoke or anything, but at the moment is Apex Mocks. Now, Apex Mocks is open source and built and used internally by Financial Force. It supports all of the good stuff I was talking about earlier, verification of method calls, how many times things are called, stubbing, and a bunch of other stuff. And at the moment, it generates all of the mock classes for you. So you saw all of that nonsense I was writing on the board for my simple example, putting on the slides for that simple example. There's a small Java program that you use with Apex Mocks that generates all of that nonsense for you that you need for it to work. So, all of that sort of grunt work you don't have to do. You just get on with writing your tests using the classes they provide. Now, the next one, and this is why the safe harbor is in there, is the Stub API. Now, I'd love to have shown you some examples of this, but I just didn't get time before we came here to Dreamforce, so unfortunately I can't. But it's a Winter 17 pilot, and it provides native interfaces and methods for creating your own stubs and mocks on the Salesforce platform. There's more details in the Winter 17 release notes, and you can request access to the pilot fairly easily. The link's at the bottom there. You probably don't want to type that in. You're probably better off just Googling for Stub API Winter 17. But, it's there anyway. And then on other platforms, there's mocking frameworks for basically everything, or at least any, halfway popular language, because, there's some outliners out there. But, you've got Mockito for Java, Jasmine's very popular for JavaScript, the unittest.mock library for Python, which is just one of their standard ones, Mock in C#. So many more out there. There's a lot of clever people doing, a lot of great stuff to make writing tests easier and to make your test better. So, in summary, this all seems like a lot of effort, you're probably thinking. Writing tests is already a pain in the backside anyway. It takes, normally twice as much time as it took to write the actual code in the first place. Why do I want to increase the complexity of my tests? Well, there's a few reasons. One, your tests are now protected from changes to modules they depend on. So, if you tested the controller and the service separately, and then you go and change the service, both of those tests are likely to break. And that's not really what should happen, because only the behavior of the service has changed. This was the point I was trying to get at earlier. All the controller does, and all the controller's behavior, when you're thinking of it as a unit, is to get the data from the service. It doesn't care where the service gets that data from. All it knows is that I should be getting it from there. So that test shouldn't break, at least in terms of a unit test. I say your tests only test one thing or one module to be more accurate. And so they are actually unit tests, testing an individual part of your application independently. And by going along the lines of doing all this dependency injection stuff, it actually makes your code more flexible for the future. If later on you want your exec to get completely different data, you could inject a different service rather than having to put complex logic in your query. You can do all sorts of stuff. Like I say, getting stuff from configuration. You can stick all this in custom settings, custom metadata for saying what services should be used in which scenarios. So it allows you to do a lot of really good stuff. But what I really want you to remember is that integration testing and application level testing is still important. I'm not saying rewrite all your unit tests or your existing unit tests, like the first one I showed you, to use mocks and then, just forget about the way you were doing things before, because that's daft. Those tests have value because, when your user goes to a page, you want to verify that it does the right thing all the way down. Your unit test doesn't care that the controller, while the controller doesn't care that you get the list of whatever from an API, the Salesforce database, or whatever else, your user does care. They care that their page shows them what's in Salesforce if that's the purpose of the page. So you still want those sorts of tests to test that sort of thing. But what I would say is don't try and do integration style testings all the way down your tree, because when you get to a big application where you've got lots of things that depend on something, depend on something else, depend on something else, what you end up doing if you write those style tests all the way down is you have the top level one and you'll strip a bit out and have the exact same test at that level. You'll strip a little bit more out and have the exact same test there and a little bit more out. And they don't provide any value, those ones all the way down. The top level one does, because that's where your user interacts, and that's what they see. They see the whole loop. They don't see this little part of the loop or this little part of the loop. So you should concentrate your integration testing efforts on your application's entry points. So if you think, in Salesforce world, that would be your page controllers, controller extensions, invocable methods, REST API endpoints, et cetera, et cetera. All of the places where a user interaction would start something and they'd expect an end result. And the final point is reiterating what I've been saying all along. Use common patterns so that it's easy for you and other developers on your team to understand what's going on. They can look up constructor injection, they can look up getter, et cetera, injection, all of this, and understand what you're trying to achieve. But more importantly than that, unless you really don't like what's out there, and I think you'd struggle to, well, you might dislike it, but you'd struggle to dislike it and get increased value in a reasonable time frame. Use a framework that already exists. Contribute. Like I say, Apex Mocks is open source. You can submit pull requests, issues, all of this. If we all pitch in on the same tools or subset of tools rather than constantly rolling our own, things get better for everyone. I'm not saying we should all double down on just Apex Mocks. If someone else comes up with something else that's better in the future, then we can have the two of them and they can feed off each other. But rolling your own is probably not the way to go. And that's it. Thank you very much for listening. If anyone's got any questions, then there's a microphone somewhere. I thought it was in the middle of the room, but I don't know where it's gone. Oh, no, it is in the middle of the room. Sorry, my eyes are just wrong. Yeah, thank you.
Hi.
Hi.
I'm more interested on the dependency injection part of the talk you just gave, specifically on more dynamic types of dependency injection, like the service locator, sorry,
Sure.
Pattern. I was wondering if you have achieved that sort of dynamic dependency injection on Salesforce with Apex, and how you've done it, if you've used any frameworks or what your suggestions are.
So in one of the projects that we've been working on, this big App Exchange product, we have been using the service locator pattern. And we use custom metadata to define what classes should be used in which situations, and then we use type.forName to construct them. So you can say, I want one of these. I mean, it gets a little bit messy because we don't have generics in Apex, so you have to return object and then cast it to the interface you want. But you can at least do type.forName to construct the thing in the first place. The one thing, or the one part where it starts to get a bit more difficult is when you need to pass parameters to the constructor. And at that point, you have to start doing some little dirty bits. Like I'm going to say it, but I don't recommend you do it at the moment because hopefully they'll solve this. There's a little trick you can do with toString and use string.valueOf to execute arbitrary code and do some clever stuff. Which is, I'm sure they'll close the loop on that one eventually, but we do use that at the moment to do that. So I wish I could give you a better answer. We still haven't cracked it, but we are moving in that direction. We're getting things to work with a few little workarounds and stuff.
Do you think you'd release a framework for somebody else to use?
Once it's tidied up at some point, yeah. One of the other things you can do is, rather than using a constructor, use an init method or something similar. So you have a common interface that everything goes from, and then you can have init and pass it a list of objects, which are your arguments. That's another way of getting around things. Right. But I'm playing with a few different things at the moment to try and come up with something that is a little bit less messy. But yeah, once it's usable, then yeah, I'll be releasing.
Do you have a space that maybe we can watch for? Or you have a GitHub or something?
It'll be on GitHub. So my username on GitHub is adtenant, the same as it is for everything else. So
Great.
It'll be on
Thanks
there.
a lot.
You're welcome.
Can you provide some commentary on performance using various frameworks? We have a big problem right now with our Apex test runtime, and anything we could do to help would be great.
Okay, so one of the big advantages to doing this style testing is that for the majority of your tests, you can make them SOQL-less and DML-less, because if you abstract the SOQL queries behind services or behind an interface, then they never actually have to run in the unit tests. And the same with your DML operations, because they're the things that take time, especially when you're doing bulk testing. So it won't improve the runtime of your integration tests, but certainly you can have a lot more unit tests running, because if they're not touching the database or the fake database that's used in tests, they run so much quicker. It doesn't matter which framework you use, or even if you don't use a framework, if you can remove SOQL and DML from your tests, then they'll go like that.
Cool, thanks.
Regarding integration tests, do you recommend or prefer the Apex framework over something like SoapUI or Selenium?
So that'll be more the sort of UI testing side of things that we're using Selenium. So when I'm talking about integration tests, I'm talking about code level integration tests. And for those ones, I just tend to use, you want to mimic what's happening in real life as much as possible. So just using regular inserts, queries, all of that sort of stuff. In terms of UI testing, the only one I really have any experience with, and I've never need to look for anything else, is Selenium. It does exactly what I need, and it works. It's a bit of a pain to get working with Salesforce, I'll give you that, because a lot of things don't have IDs where you'd really want an ID to go and find the thing on the page. But you can get it there if you like.
Yeah, thank you.
Cool. All right, I think that might be it. If anyone doesn't want to ask at the mic, feel free to come talk to me outside after the session. Thank you.